Welcome to CS 161, discussion 9. This is Web Security 3, and I'll be doing the walkthrough for today. So we start out with phishing attacks. Phishing attacker tries to gain sensitive information by tricking users into going to a fake website, a fake version of a website that they trust. The attacker might convince the user to go to what appears to be their bank and enter the username and password. So what are some ways that attackers fool users into doing this? Well, we have a couple of different ones. First is that we might have subdomains that look like top-level domains. So if bank.com is our actual domain, maybe we control, as an attacker, b.bank.com. And if we can trick a user into thinking that this and this are going to the same page, then if we control this link right here, an attacker will be able to trick a user into entering their login details on this page instead of the actual bank.com. So that is subdomain. Other attacks could be changing one character and then buying a domain under that name. So if you have Bank of America.com, and this is your real domain, maybe an attacker purchases Bank of America.com without the E. And if you're just glancing at this as a user, it might look really similar, but in reality, it is a completely different website. Other attacks include sending emails that look like they might have recent information in it. So for example, if an attacker takes over a friend's email address and somehow gets access to that, then they can use that to trick other users into giving up personal information. So any of those attacks are ways that attackers might go about doing this. So what are some defenses against phishing? Well, one of the most obvious ones is to make sure you know exactly what links you're going to. So when you are clicking on any links, you want to make sure that the link is exactly what you expect and nothing different. And something that you might want to do is, instead of clicking on a link, typing that link out in your browser sometimes will help you catch errors, and it'll also make it so that an attacker can't hyperlink and trick you through hyperlinks. And so in terms of those questions, some of the ones that we have are verify URLs manually. Others are don't click on unexpected links in emails. And other potential solutions to this include looking for, in email specifically, looking for things like typos or other things that look wrong. So look for typos in emails. That's a pretty common sign of a phishing attack. Lots of phishing attacks are inclusive of typos or things like that. Cool, so that is phishing and phishing attacks in general. Let's move on to web tracking. So when you visit a website, what information can that site get about you? And how can a business learn about other sites that you visit based on these websites that they control? Well, this first question is asking, what do sites get about you? So technical information that they get are time that you requested it, of course. They know what type of browser you're using. They know what OS you're using. They know what language you're using. So if you're using an English configuration on your computer versus a Spanish configuration, they'll know that. They know your screen size and screen resolution. They know your IP addresses, and they can generally detect a location. They might be able to detect a location, rather, from this IP address. But this location will be a general location, so not precise. For example, if you're signing in from Berkeley, they might know Berkeley, CA. How can a business learn about the sites that you visit and construct a detailed profile based on your web habits? Well, any website that is using ads, so for example, Facebook ads, these websites, if they have Facebook ads embedded on their sites, are basically telling Facebook that a user is, loading that ad from a particular website at a particular time from a specific device. And so if you have a bunch of websites, each showing this Facebook ad, Facebook essentially knows that all of these ads have been rendered, and they know what sites they're coming from. And they might be able to tell what user is accessing these things through a fingerprint. And so if Facebook takes all of these metrics, things that don't usually change, and they associate that with a particular user, and they also know that all of these requests are coming from sites A, B, and C, Facebook can tell that you have browsed sites A, B, and C. And so this is one example of a way that a business might go about doing some sort of tracking across the web. All right, so that is web tracking. On to question 2, clickjacking. So in this question, we talk about clickjacking. Let's go through some of these problems. So the first one is asking, in smartphone browsers, the address bar containing the page's URL can be hidden when the user scrolls. What sort of problems can this cause? So if the address bar is hidden by default, one thing that an attacker might be able to do is place their own address bar on a website and trick a user into thinking that they're on sites that they're not actually on. So in this case, we can trick user into thinking a fake address bar is the real thing. And this sort of attack might use some JavaScript to scroll the page at first and make it through before it renders its fake address bar. And so it's going to scroll down, that's going to hide the real address bar, and then JavaScript on the page will show the fake address bar. And so an attacker will be able to trick a user into thinking that they're on some website when they're not actually on that website. Part B is asking about notifications. So smartphone users are used to notifications popping up in their browsers as text calls arrive. How can attackers use this to their advantage? So if an attacker simulates a notification that looks like a real alert, they can essentially use this sort of clickjacking attack to get a user to click on something that is bad, that is evil. So essentially, we can fake a notification. And this is like just solely using UI here. So it's not an actual notification, it's just a fake notification that looks like a real one, and they can get the user to click on a link. And that link might lead to anything malicious that the attacker wants them to go to. All right, part C is talking about QR codes. So QR codes haven't really taken off and become ubiquitous like some thought they would. Why might this be the case? So one of the things that this method of QR codes, or I guess one of the places where this is used is overseas. And so actually in India, QR codes are used very, very frequently for things like payments. And so when you go into a store and you're paying and you're buying something, you scan a QR code that's at the dashboard or at the checkout counter, and that's how you do your payments. And so one attack here is that an attacker can just walk around all of these stores and slap their own QR codes on top of QR codes that exist in stores. And so if an attacker just puts a sticker on that looks like the real thing, but it's not actually, this is a pretty big security vulnerability, because then the attacker can get the user to open up ambiguous links and really spoof the user into thinking that they're on websites when they're not. So placing, I guess to put this into a response to this question, there's no real integrity here with just QR codes. You see a QR code on the, at a checkout counter. You don't really know who put it there. It could have been an attacker. It could have been the actual user. You don't know what it leads to until you open it up. And so that's a pretty big vulnerability as far as QR codes are concerned. So this first question is talking about TCP and UDP and how they relate to IP. Now, remember, TCP and UDP are within the transport layer. And IP is one layer below that at the network layer. So whenever you see, communication happening over the network, you might see something like TCP IP or UDP IP. But you won't see something like TCP UDP, because these exist at the same layer. And so you choose one of these two combinations. Part 2 is asking what are the differences between these two protocols and which is considered best effort. So TCP is a connection-oriented, reliable byte stream service. So let's break each one of these down. All right, so connection-oriented, what does this mean? Well, this is saying that in order for TCP communication to happen, we need to do a handshake first. So we first establish a connection before we actually send any data across. Reliable means that if packets fail, we might retry and send packets again. And so one of the things that we know is that packets will always be received in order. And so we won't send packet number 3 until we know that the other person received packet number 2. So by reliable, we mean that packets will be sent in order, and we might retry. Now, byte stream, well, this is basically saying that we have lots of data that might be going across on any given TCP connection. And so you might have a 1 gigabyte file being transferred. It'll just be broken up into different TCP packets, and it'll all be through the same TCP connection. So that's what we mean by byte stream. Now, UDP is quite different. UDP is datagram oriented, and it's unreliable. So what do these two things mean? Well, datagram oriented means that we are essentially sending individual packets, and there's no actual notion of a connection. So we just send single packets. And unreliable means that we don't retry if a packet doesn't get across. We have no idea. There's no acknowledgement. So because of this lack of knowledge and lack of what's actually being received on the other end, we call it an unreliable service. So no guarantees. And we won't retry. We also don't know if we received, or if our packet has been received. All right, and what do we mean by best effort? Well, IP is a best effort service in which it tries once to deliver a packet, but it has no guarantees that it'll actually deliver that packet. And so what we do at TCP is that we assume that our packets might not always be delivered, and we make sure by receiving a packet back from whoever we're sending it to, that our packet was in fact delivered. So IP and UDP are best effort, but in TCP, we build on top of IP and we make this reliable, where we know that our packets are being received, and if they get dropped, then we can try sending them again. And so that is sort of the difference between best effort delivery and how we build on top of this imperfect system to ensure that our data is getting across as we want it. With that, that is the end of the walkthrough.